Okay, here's a video response to MonkeyDude1313's faster edge pairing tutorial. And I noticed that when you go to pair the last two edges, or any edges for that matter, if you have a case like this to where it's this one and you want this one to go here, he did some algorithm where you have to bring it up and then do some random cube rotation or whatever to get it to where you wanted it to go. Something really quite difficult. But the way that I saw Nakaji doing it, it's really quick and you don't have to rotate the cube. It's RU, R prime F, R prime F prime R, and then look, it switched the edge. And I'll write this in the description and as an annotation, but it's decently quick to switch edges. And also, when you're down to the last two edges, instead of doing some algorithm like PogoBat shows, you can just with these two, just bring it over, do that switching algorithm, and just bring the slice over, and it solves the last two edges on that one. Now here's another the same thing, just if you already had it sliced, you can, to get this edge here, just same thing, and then do whatever edge pairing you like. I just use freestyle, but okay, and then same thing goes kind of for the 5x5. If you have, I'm just showing different examples. You have the blue and red here, and just switch it, and just do whatever. But I mean, like if you had, let's say, and also there's another way of doing this. If you have just hold on, I'm just setting up cases right now. So if you had just this piece here, instead of doing the whole entire move, you could shorten it, because this red and green piece is here and this green and red piece is here. You can just do the front R prime F prime R, and it puts that edge here, and then you can just slice over and bring it back over. And also, if you see a case where it kind of looked like a parity case, and you can find the other, and you have the other piece, I'll just bring it over just for the sake of argument. So here's the piece. You can just bring it over and then do that algorithm to switch the piece over, and it's really good at switching on this one. And now for the 6x6, because I like even cubes because you can switch the edges a lot easier every time I pair edging. But if you have one last piece left, instead of wasting time doing a parity algorithm, you can't already recognize it. What you could do is you could just bring this over and replace that piece and do that switching algorithm again, and just bring the slice back, and you have the edge solved. So it's pretty viable in switching edges. I'll show another example in a moment. Last one here's the 7x7. Here's another example of, if you have all your, I just freestyle, you can do, if the edge is right here and you just want to put it here, you can just do the front, that. And I've also noticed, because it's a little difficult to do cube rotations and do, not really, but to do the one that MonkeyDude said on the bigger cubes, it starts to become a little more cumbersome than usual. So, plus this one's easy. It's just, you can get a pretty nice flow to it, and a decent amount of speed. And it's really quick at switching edges. So that's that. And as a side note, if one could memorize this F2L case, I doubt anybody would really use it. But if you had this matching color on top and whatever side you're solving on the bottom, you could use that switching algorithm as just another F2L case, to where instead of bringing it over and making a pair and then putting it in, if this was already unsolved and this one's over here, I'm not sure if it's already written as an F2L case, but it's decent. And that's it.